There we go. All right, so here's another example, more like yesterday's, that will run into some of the issues we ran into yesterday. So when we've got x's downstairs in the denominator, and we know that finding factors of the denominator or common denominators is going to be important here, then what we need to do is factor these denominators first. X minus 3 is factored, 3 is factored, but x squared minus 9 can be re-expressed as x plus 3 times x minus 3. So this now becomes 1 over x minus 3 plus 1/3 equals 6 over x plus 3 times x minus 3. We have a couple choices here. Let's just get rid of one fraction at a time. We'll get rid of this fraction. Or not get rid of it so much as make it not a fraction anymore. What could we multiply both sides of the equation by to make this not a fraction anymore? X plus 3 times x minus 3. We multiply by this denominator. But if we do it on the right-hand side, we also have to do it to the entire left-hand side. Now here, because there's no distribution, there's no plus here on the side, we can get right away with doing the cancellation, and we are left with 6 over on the right-hand side. But on the left-hand side, we've got some distribution to do, so let's do that before you cancel. If you don't, that's where mistakes come in. So x plus 3 times x minus 3 times 1 is just x plus 3 times x minus 3. The denominator of this first fraction becomes x minus 3. So that's this product times this. Now we have to go this product times this. This just becomes x plus 3 times x minus 3 over 3. Now we can do some canceling. So now we're down to one fraction. Now, so how do we make this so it has 0 fractions? We multiply everything by 3. Okay, both sides of the equal sign by 3. So this side becomes 18. This side becomes 3x plus 9 plus 3 times x plus 3, x minus 3 over 3. These 3's cancel, and so now everything's non-fractional. So let's rewrite 3x plus 9 plus, this becomes x plus 3 times x minus 3 becomes x squared minus 9. That's the difference of squares pattern. And that is equal to 18. So now I'm going to go back to the top here, and then I'll erase everything below. But I'll write this up again out to the top. We've got x squared plus 3x plus 9 minus 9 equals 0. And excuse me, the other side is 18. And now let's clear off some more space for us to work. And still stay within the field of the camera. So, when we've got an x squared in there, and we're trying to solve, what do we always have to do? It's factoring, but before we factor, we need to do what? See, my concern, let me get that blue pen wherever it was. Oh, it's in my pocket now. My concern is that this tells you nothing. I've got two mystery objects. They multiply together to give me 18. What does that tell me? Nothing. What do we need to do in order to be able to use factoring to solve? What key fact is there? Yeah, things need to be equal to 0 because we know what to do when something times something equals 0. So we're going to subtract 18 from both sides of this equation. X squared plus 3x minus 18 equals 0. And then we start factoring. So this is x and x. We need two things that multiply to give negative 18, add up to give positive 3. That would be plus 6 and negative 3. 6 times negative 3 is negative 18. 6 plus negative 3 is positive 3. And now that we've got this set up, we know that our solutions, potential solutions, occur when x plus 6 equals 0 or when x minus 3 equals 0. And this occurs when x equals negative 6 or x equals positive 3. Now, ordinarily, that would be the end of the story. But remember, we started off with these fractions, and we have to make sure that both of these solutions work in those original fractions. We saw yesterday a case where it didn't, and I'm betting we'll see today on this type of problem a case where it won't. So let's look at the original fraction again. 1 over x minus 3 plus 1/3 equals 6 over x squared minus 9. If we substitute 3, do you see the problem? There's zeros in the denominator of these two fractions. And that doesn't work. So 3 is what we called an extraneous solution. Or that's what the textbook calls an extraneous solution. I fade back from that because some people think here extraneous solution and think it's some type of solution. It's no type of solution at all. X equals 3 simply does not work. So now we try to see what happened if x equals 6. We have 1 over 6 minus 3 plus 1/3 equals 6 over 36 minus 9. This should be a negative 6 here. So this is negative 1/9 plus 1/3. Is this equal to 6 over 25? This is negative 1/9. No, 27 should be. Plus 3/9. Is that equal to 6 over 27? Is 2/9 equal to 6 over 27? Sure it is, because 6 over 27 is equal to 3 times 2 over 3 times 9, and the 3's will cancel that and leave 2/9. So x equals 6 checks, or x equals, negative 6 checks as a solution.